This is a very hard decision to make, but I will probably have to do something about it because, first of all, there are multiple problems here. This entire breadboard, I have it there for a couple of months, 2, 3, probably 4 months, and it's just laying there and doing nothing, and I cannot access it because it's holding all the stuff that is functional for this circuit here. They are in link everything, and I cannot take it out. Also, that's this breadboard, but this breadboard I don't really need it, but that one yes. That's one problem. The second problem is that I discovered a little bit of this circuit is functioning well enough. But I have a tiny little bit of problem, the speed problem. If I'm turning, I'm not sure how well it will show. So now if I'm turning the speed, this is the slowest, toward the slowest, as you can see. And I like it as it is. But as long as I'm turning, as I'm reaching this faster, or the other end of the pot, the maximum, it will not be linear. It will be like, and that very small track. As you can actually see the wiper of the pot there. You can actually see it when it's reaching almost the end. Is starting extremely fast. It's jumping pretty much to a very high frequency, and it's very hard to control this high frequency and high speed. And my motor, what it did to my motor was jumping too fast to a faster speed too quickly, and it just freezed. It didn't spin because the travel was too abrupt. I want it with more speeds, pretty much. You know, the slower, faster and faster modes. To do that, I have to operate here. To add, I discussed this problem with my friend from England, and the only option that I have for a 5x5 circuit at least is to insert a couple of capacitors and to jump between them with a jumper and choose the range of frequency that this will operate and make it even slower than 1 hertz. You know, even slower than right now. Right now it's very slow. It's like 1 per second probably, 1, 2, 3. You know, it's probably 1 per second, and even slower. I can make a jumper for that. You know, with a bigger capacitor or something. Another problem was the circuit that I built it. I'm not sure exactly what I did here, but I cannot repair it. I cannot change it. I cannot take out this potentiometer and check the wiring because a lot of wiring are beneath it. And holy fuck, it is a jungle of wiring and components and everything, and I cannot possibly intervene there easily. So that's the biggest problem. If I want to repair it or upgrade it, the visibility is very much abstracted. I cannot understand anything what is going on there because they are all put one on top of the other, and it's not good design. This is good design here. This board is very aerated, you know, it's having a lot of air, a lot of space. This is kind of good as well. This is also very good. It's having a ton of space. I can intervene. I can change stuff. This part here, this little module, yes, is good enough. And this as well, here as well. And let's say until here, not there, but here. So until here is good. But from here to there, this entire section is extremely complicated and one on top of the other, and very ugly, I don't have space to intervene and to change stuff. And my idea, the first problem that I have to resolve, the important problem that I have to resolve is to change the way the speed is running, you know, to make the modes of the speed, and then to add this circuit that is already functioning right now with a single speed, that it is this capacitor there, that brown one is dictating the speed of what I'm having here. And that's the important circuit that I have in mind to actually change what I have here with that. And it was a little bit of debate, very short debate, but it was a debating because I was extremely unsure what to do with everything that I'm having here. Like I said before, this board is occupied doing nothing, waiting, you know, for a couple of months, and I don't like it. And the second thing, the debating was like this: either I will package everything, I'll put it in the box and say this is it, it's done. I made the circuit, is working, is good enough, and I put it aside as a side project that I did it some time ago. And when I will open it after a couple of years from now, I will wonder what the fuck did I did here. I will not be able to remember too many details because there are too many stuff here that you have to consider, that you have to remember and to take in account. Second option is to actually pursue the idea of functionality to make it better. It is my intention to make it better, and I can modify this entire circuit, well, or some parts of it. Like I said, only this part here. And I actually stayed with all this stuff in front of me, and I was looking on the circuit on my monitor screen, and it confirmed a lot of stuff. It is exactly as in the circuit that I have, but I have one single thing I added probably very late, and it was a trouble here. Here is 7474. The writing on the chip is not visible anymore because it's all this stuff on top of it. But this is a flip-flop, 7474. And this flip-flop is having 2 flip-flops in it. One on the left side and one on the right side. And I used both of them, but in my circuit diagram, I only have only one side used, but not the another. This is only cycling. This button is doing the cycling through steps. One is not automatic like it is right now. I can show you actually. I switch it to manual pretty much, and this is doing not step by step. Only only one automatic and then it's stopping. Okay, so this is doing that. And if I'm switching from this, this is to 16 and here is to from 1 to 15. And depends what I have there. So it will count to 8 because this is all 0 and this is 1 and it is 8 and it will be 7 and this is the 8 or the 1, whatever. So this circuit that I added here with this other side of the flip-flop, I didn't put it there. Unbelievable. In my original circuit. So I will have to add to the circuit, the original circuit that I have there, to add this little functionality that I have no idea what I did there. And also I have a green LED as well, you see? It's lighting up. And I have no idea what I did there. Shit, I didn't put it. What a mistake. But the debates. Getting back to the idea. So I had the idea either to modify what I already have here, or to build it again from scratch using some newer chips that I got. I got this entire board that I have here is a BCD. It's a binary. These are the 4 wires from the binary 7493. It's a binary. It's switching. Is counting in binary pretty much. And these green LEDs are showing the display for the binary counting. And the signal is going there. And this is a BCD, binary converted to decimal BCD. And these are the decimal up to 16, up to 15. But counting 0 is 16 countings pretty much. All the countings that this the entire range of countings that this binary is performing actually. It's very, very big. And I have a single chip. I built this until that chip was arriving. So in the time it was traveling to reach my home, I built and tested and already was made this entire thing. And I spent a lot of time and yeah, it's kind of, I'm attached to it. I don't want to lose it or to change it with that chip anymore. So if I have to remake everything, I will probably have to put aside all this project and use that chip, and probably the rest will be the same. Most probably that's the same stuff that I'm having here. The only changing pretty much, I will change this entire big board with one single chip, and it's LEDs of course, and then I will have to add this little circuit that I'm having here, and then this little chip. You see, it's a chip here, L something 293, I believe it was, and in 2003 in parallel there, and some bridge rectifiers for the motor, the diodes used for the coils, yeah. It's a ton of work, and I don't want I don't want to make it. And remember, this is using 2 voltages. 1 voltage, 5 volts for this entire circuit that I'm having the logic, and probably that one as well. On this one actually, he needs 5 volts as well for one part, for half of the chip. It needs 5 volts to drive it, and another voltage for the motor itself that is passing through this chip to power the motor. So 2 voltages, and shit, it's a bit more too complicated and too big. It's very, very big, and I'm very proud of what I'm having here, of course, but these are changing by themselves for some reason. Yeah, I have a little bit of issue. I believe it's a button. You see, when I'm touching this, is very touchy, and I observe it while when it's like this, is not doing anything when it's pressed, but when it's unpressed, it's doing something weird. It shouldn't, but it does. Motherfucker. This is the only problem. Most probably, if I will change this motherfucker with another button, it will not be this error anymore. This is a minor problem comparative with what I have here. Oh, I have no idea. I am extremely inclined to box it, to put everything in a box and forget about it. I'm extremely inclined. Yeah. I have no idea what to do. I really have no idea what to do and how to proceed. It's such a hard decision at this point in time. It's a very, very hard decision what to do. If I will have to operate here, holy fuck, what I have. And that missing circuit, that is the most problematic. This missing circuit that I don't have it. I don't know exactly what I did. I know something, but I don't know exactly. I should rewatch my older videos. Holy fuck, it's it's very, very complicated. That's it for this part, and I'm not sure if I will even publish this movie that I'm having here, unless I will actually start doing it. Wish me luck, because I really need it. Holy fuck. Your future good luck will help me right now in the past when I'm having the problem. So wish me good luck in the future to have good luck now in the past. Q12 philosophy. All right. Well, I was wrong. I didn't look very well on my circuit. I have the circuit for this in Proteus, and this transistor here in the middle is a NOT gate that I made it from one transistor pretty much, and this NOT gate is connected with very tiny and fragile. You see there? Holy fucking shit, what I did here. But this button, I was mistaking it with something else, but it's counting a number of steps and then it's stopping. And when I look specifically for this function, I did find it in my circuit, and it's having this NOT gate as well. This transistor that is having here, this SMD transistor with a resistor on its collector there, and probably this is the base. I don't know. Maybe that is the, I don't know. Whatever. And this is a resistor put. You see, it's a resistor on the side there. It's a tiny resistor there. This is the LED, the green LED, and this is its resistor. Holy fuck. So it is indeed. I have this circuit on the main circuit. So that's good news. That's good news. And yeah, shit. I suppose this will be a lesson for me in modularity. I love modularity. I like to make stuff modularly, but they are not modularly enough, it appears. So this board was here, and I unglued it from there. and I put it aside. Also the rest of the circuit that was on the breadboards, and I literally had to cut the paper here, as you can see. And lucky me, this pad was up to here, as you can see. It remained there assigned where the pad was, and it was glued. That's why I'm saying I was very lucky right now to cut in a straight line. And if it was bent underneath, I was having to cut around it. But being glued, I just remelted the glue and push the pad. You see, I push it underneath here, and I could cut straight in a straight line, which is excellent. So until here, including this switch, it's good enough, you know. But here, this circuit is a disaster, and I will have to. It's a disaster from the point of view of repairability. I cannot repair it easily. It's all one on top of the other. Very, very close gaps, close, too tiny everything, and I cannot enter with my solder iron. I have to make it a little bit more wider. And my idea is, as you can see, I even saw it here. You see, with the black sewing, you see it, and there as well as an X. You see, and there probably also here. So I will probably have to cut this box that I'm having already here and make all this circuit that I'm having here a bit more wider like this, you know, to get more room in it. And also that problem that I said I had with multiple speeds, and it will be inserted on this larger module here, and then this will be shifted. All this module will be shifted down here somewhere. Previously it was here, remember, and now I will shift it there, and everything will have space here for only this part, for its upgrade pretty much. But this is interesting. It's an interesting development. How I'm upgrading this circuit. The entire cardboard I'm cutting literally in the middle of it, in the middle of the logic, in the middle of the boards, right in the middle. And I'm replacing only this part. I'm redesigning it, and probably I will use the same components that I'm having here. I will desolder everything, and I will reimagine and redesign it and make it bigger and more accessible and more easy to, like this. You see how very extremely well, you know, I can get into it and repair it and change stuff and look and see the problems if there are some, like this motherfucker button that is also, I will have to change that fucker as well. But yeah, pretty nasty update of that entire circuit. But I decided to make it. I said to myself to have courage and deal with it. It's very hard for me to do it, to cut like this, and because it is a complicated circuit. But I have the diagram already, and that will. I'm counting on the diagram that I'm having it on my computer. And if I was not having that diagram, I could never get into it to start doing anything. Not even like I am right now at this moment with cutting it and everything. Yeah, wish me luck, because now is the hard part when I have, well, everything is hard, you know, but I will have to redesign this part, and see you later. Pooh, holy shit. This is crazy. This is a very crazy step in the development of this board. Holy shit. And I'm not sure if I will change this. I'm not entirely sure. I will think about it. Hello everybody. This is the middle of the summer right now. 16/07/2023. On yesterday I spent a ton of time to build this circuit. Crazy. It looks like a child's play, but in reality I had to work my ass off to actually build this circuit diagram. And let me open the file. So this is an update to my stepper angle, and I made this only the partial circuit because I don't need the rest. It's way more than it is here. And I have this circuit for a while, and well, I was talking with my friend. He actually helped me, my friend from England, spotting some little tiny bit of mistakes that I did previously, and I did correct them. Here is everything corrected. So what I needed is this part here, and also this part, and that's it. The rest I don't care. I leave it there for context, but to see where the other data lines are going. But this is the thing that I needed to make. Let me show you something that it was before. So this is the last circuit that I used and had, and it was having only one capacitor here, this one. And I wanted more speed. What I did, I put a ton of different values: 100 micro, 10 micro, 1 micro, 100 nano, 10 nano, 1 nano, 100 pico, and 10 pico. I didn't put 1 pico because that is way too low. And pretty much what I did here, I'm changing the speed at which the entire clock is running. And also I'm having this 1 mega ohm potentiometer here that is varying quite considerably. It's actually working here. I can show you actually. So now when I'm playing it, nothing is connected there, nothing is moving, nothing is pulsating. But if I'm switching to this guy, it should work. No, it should. It is to 100. Maybe the speed is not good enough. Something is weird. Yeah, that was the problem. All right. So so if I'm moving the potentiometer, as you can see, it's changing the speed. Very extremely fast. Actually, you watch this clock here, these numbers, and they are showing you how fast everything is actually moving. And this is 100 nano, and this is quite slow with 1 micro. You see, 49, because the potentiometer is lower, and when I'm getting upper, is a bit more faster, and it's quite quite good, and this is working as well. What I'm having here in the simulation, this is what I wanted to show you. But the main, so this is an upgrade pretty much. So what I did here, I've upgraded the circuit to have more speed. That's it. And to upgrade it, I had to take down the entire circuit. I'm not sure if I let me show. Yeah. So this is how it was looking before I disassemble it. I pretty much disassemble a part of the circuit. So this is the entire full circuit that I'm having. So from here, like this, you see this part, I took it out, I cut it from there because it's cardboard, and I took it out. You will see it in a second, this part. And I was complaining, I was talking with my good friend from England, and I was complaining about in that current situation, in this form that I'm having here, I was having it here, it was too compact, everything too close together, too hard, way too hard to intervene and change a component and correct something. If I wanted to change something that was burned, or I was checking actually this potentiometer to see if it was having a correct link, and I couldn't reach it. I couldn't see what it's everything way too close together, way. It's a very bad design from this point of view of not being able to come back and repair it or change it, the circuit. So this was another good motive for me to intervene into this project and cut it. As you can see, I literally cut it there, and I had to disassemble everything, and I reused a ton of parts that I already had on this module. So only this module I had to change it and also to upgrade it, because like I said, I'm adding all these capacitors and all these jumpers. And as you can see here in the 3D view, that was a bit of a problem because if I was making it directly in reality, it is a problem of space. And here in the 3D environment, in my 3ds Max that I'm using here, it is not a problem of space. I can design it freely, but until I get to design it freely, to place all these components and also to make, I had to also add new components, and I had to make them. And I have here all the components that I'm picking them up, and I'm choosing from them, and I'm using whatever I need, and I'm placing it here in my actual circuit that I'm building. And also I have an original file. This is not the original file. This is the work file that I'm building the circuit inside it. The original file is only having these elements, and I had to update that and then merge particular elements that I created new into this one. This program is quite old, and it's not easy to update something from one file to another. And I managed to make it, but it's like scratching your head with the foot, with the leg. It's like that. It's quite hard. But I managed to make it, is what I'm saying. And back to the problem, the space problem. In reality, if I was designing this circuit here directly in reality without the 3D help that I'm having right now, if I was making a distance mistake, I was making it a bit more longer. Holy fucking crap, motherfucker. But here, you see these yellow lines that I'm having here, this represents the distance, maximum distance that I am allowed to build this circuit. Mostly on the width here, it's 85 millimeter here. I was limited by 85 millimeters, and I made it a little bit smaller. In reality, it's even a little bit more smaller than this. Here is a bit too wide. But here on the length, I have no limiting, and I can go down as much as I want, but not too much. But that's the idea, I had some limits. And in reality, if I was to build it directly without, a la prima, without from one shot, and if I was making a spacing mistake, like making it too large, adding too much components somewhere that it needed not to be that large, holy shit, I was scratching my balls. And that's why I said, no, it's too complicated. This circuit is a bit too complicated to make it directly in reality. So I will jump into 3D, because I can move it freely here in 3D. I can literally move it anywhere I want, whatever I want, wherever I want. And I can tweak the dimension, the general dimension of the entire board, whatever I want. And that is the case. This is exactly the case, exactly what I did here. As you can see, this circuit on the bottom here is literally put here without any thought. I didn't make it nice. I just put it in the middle. And I really don't care. I'm actually thinking here on this section, I'm kind of thinking this circuit like this, like it's having 3 sections. So this is the first section, this is the second section, and this is the third section. It's in 3 sections, you see. And this second section, I was very, very concerned about it. I didn't really know how to make it. Originally, I was thinking I will put all the capacitors here. And I didn't drag any wires, but you have to imagine that these two. You have to imagine that these two are connected with a wire. This one with this one is connected with a wire. This one with this one is connected with a wire, and so on and so on. And this one that is 10 pico is somewhere underneath everything, and connected to this pad. And yeah. So originally, I was thinking to add the capacitor directly here on the pad in line with all these jumpers. But then I thought, I changed my mind. I changed my mind a couple of times actually. And I said I need space for my fat fingers to actually grab this jumper and take it out from there and move it wherever I need to move it, and then change it and get it back, and not to hit with my fat fingers the capacitors to be in the way. So that's why I put them the fuck aside.
and be careful with the design of how I'm building and not to be in the way. And also, as you can see, it's extremely leger in my language, spacey, as spacey as I could make it, as normal as I could, pretty much, and to make it not too spacey, not exaggerated to leave too much space, but spacey enough that I can intervene with my soldering iron and change the component and see if it's a problem, check with my tweezer, with my needle, if something is broken, if something will go shit ways, because these circuits, you must think of them, they will broke because they are on cardboard. I have to keep in mind this possibility. And yeah, and I also changed this 3D circuit that you are seeing here with the components that I put them in reality. How I work it actually. So let me make you a little bit of drawing here. It's a funny drawing. This is me, and this is my arms, how I'm working on my table, and this is my legs, and like that. And this is my chair, somewhere there, and this is my table, very big table. And here in my back is my monitor. And I had to turn my head and my body around like 100 times and look on this 3D model that I'm having here. And sometimes I had to get up from there and move it around here on the monitor to actually see the placement of what is behind it. Not fun at all to work like this. But it did the trick. It did the trick. I mean, it helped me because I literally stayed and think a lot yesterday when I built it. It took me like probably 4 or 5 hours to make what you are seeing here, or 6 hours probably, continuous work with very short breaks, very short breaks. I kind of worked non-stop, and I also had to make some components, some new components, the capacitors, which are not that big of a deal, but if you have to make them, it will eat time. And also the texts, I had to add, how to arrange it, and a lot of stuff. Also the wiring, rotating it, changing a lot of stuff. I changed a lot. And but the most important thing is that I made this upgrade with the jumpers, with multiple capacitors, with multiple speed. I write it here. This is a speed upgrade, so multiple capacitors. This is the upgrade that I made, and also in the same time I'm shooting 2 rabbits with the same shot and making it spacey, a little bit more spacey, a little bit more easy to intervene and change if something is broken. Before I had it extremely close together. I believe this is the original, yeah. So it was a jungle everywhere. It was a fucking jungle. Look at this. What the fuck? This is the 7474. This here. Let me put my red marker here. This here is the LED, the green LED, and this is the second LED, or the first LED. So this is LED 1, this is LED number 1, and this is LED number 2. And I'm using both flip-flops, both circuits, is having one on the right and one on the left, and I'm using the entire chip, both sides of the chip 7474. And when I built it, I had to move. It was very hard. And if I want to repair something, get the fuck. It's crazy. It's crazy to repair it. It's crazy, and it's very hard. It's almost impossible to repair such catastrophe. The only problem was, like I said, this part that I cut it off, and I'm remaking it, and I'm redesigning it, and also I'm upgrading it pretty much. And to upgrade it, I had to literally cut pieces of it like modules. As you can see, it is having a little bit of modularity already. Here, somewhere there, I can barely see it. Somewhere there, like that, is a square where the 555 circuit is with its pads. And I put my knife underneath it, and I cut the glue, and I deglue it. I unglue it from there. Also, this circuit board as well with this. I see on it. This one as well was its own board like this. You can see it a little bit there, and that's it. And this guy here, actually this was an entire circuit board, and I cut it here. I cut it between this part and this part, and I moved the 555 board more to the left, and I inserted this guy here. I inserted it, and a lot very extremely hard to repair something that if it's broken there, and I had to remake it because it was very bad design. And the entire circuit is like modular, and I use these modules. I desoldered every wire, every link, but not every component, because like I said, it was like a module, and I reused these modules with the components on it as much as I could. And I did remade. Right now when I'm making the video, I made it all this part. I moved this on the right side, and this guy here, the potentiometer, I moved it on the left. I switched them pretty much. You can see here in the, you see, it's way more spacey right now. I can intervene, I can repair it, I can change if needed, anything. And that was the main problem, one of the main problems. And what I'm saying is that not everything is like this, full of stuff. This is looking elaborate and complicated, but really, if I'm getting with my iron in it to change something, I can do it. But here it was practically impossible to certain components. I couldn't get into them at all. Like I said, what I built already, and I tested it. I actually tested it. I put a capacitor, a temporary capacitor, from here to here to actually make this 555 oscillate, the circuit of the 555 oscillate. In reality, I mean. And I tested it, and it is oscillating. And also these 2 LEDs that I'm having here, this 1 and 2, they are changing when I'm pressing the button. And also when I'm pressing the button, the circuit starts and stops from oscillation, because I have another line that this line is going here to this pin, to this pin of the chip, and it is commanding something else. And it's counting a number of times pretty much. The 555 with this 7474 is counting a number of times, then it's stopping. And like you are seeing here, this is the part. You see, this is the part. And one wire is very long wire, and it is this wire that is coming from here to here. I shouldn't put. Yeah, I have some mistakes here in this circuit, these capacitors and these resistors, and I didn't put them in my circuit that I have. Like I said, I had some mistakes that my friend corrected them for me, and I am very grateful for his help. He did really look at it, and he finds some mistakes. But these two capacitors here and this resistor I should eliminate from this circuit as well, because they are still here, and also here as well, and this on this side also. But I didn't include them in the real circuit. Pretty much this is it about this new development of the board, and I hope you like it. And you'll see that nothing is easy, and it was crazy. It was crazy to actually cut it from here and start it all over again. It was a crazy idea. I didn't want it. I really didn't want. What I really wanted was to put all this project, to put it in a box and forget about it, because it's complicated. It's a complicated thing, and I'm quite proud right now that I managed to make this quite essential part, this timer that I'm having here, this clock, to actually make it work and rearrange everything like I planned it here in the 3D. I'm very happy that I managed to make it, and I'm sure it will be great up until the end. And it was for some very extremely strange reason. I have no I don't know how to explain it, but it was fun. I swear to God, as crazy as it was, but working on it and cutting those modules and reassembling them and rewiring them, the wires were already cut, and I had to refit some of the wire to resync on them and find them new purpose and new links, new dimensions. I had to play pretty much with the modules that I had taking out, and reglue them, and it was kind of fun. It was a lot of work. I'm still very tired of working on this project. Only this module here, the top module, which is finished already, like I said. But it was fun to make it. As extenuating work that I did, it was hard work, but it was fun. I swear to God, it's very weird. It's very weird, but it is fun. It was fun. You know why it's fun? Because it's working. That's why it's fun. After you see it working, you kind of get a feeling of accomplishment, and it's a very nice feeling. It's a very nice feeling.
All right. I made this module here. I finished it. I actually tested it. I put this capacitor here. It's a temporary capacitor, this brown capacitor, red brown, and I link it with the wire like that there, and it's working absolutely okay. Yeah, I am pleased. I'm not pleased here in this section. It's a bit full of components and not that much space, while in this other side is plenty of space. But yeah, well, it's not perfect. And it's good enough. It's good enough in my book. Let me actually put some power on it and actually show you. All right, and let me power it up. 5 volts, 20 milliamps, and voila, it's working. And if I'm rotating from here, it's changing the speed, of course, relative to this capacitor that I'm having here. And but when I will have the bank of capacitors, it will be another story. Here is switching, and is actually stopping because when I will press a button, it will count a number of times. It will send some pulses, and yeah, and then when I will switch back, it will count continuously, like it is doing right now. And yeah, I had some problems making it, but it's made. It's okay. It's exactly as in my 3D. Well, exactly, but very close as it is in my 3D. From my table, I'm looking back to my monitor. I have to turn around at 180 degrees with my whole body and my head, of course, and look there, and to see how these pads are arranged. And I'm kind of fitting it here. And with this in my hand, I'm looking there and comparing that monitor with this in my hand and choosing the location and stuff like that. These LEDs are very interesting placed here. The yellow one that was before is not here, but this one, the green one, is from the other board. It's like this. Its leg, it cracked its leg, and it remained a very short one. And I bend it forward. This is not its leg. This is it's a piece of wire that I link it, and I bend it, and I made that contact exactly on that pad there. And this guy here, the yellow one, is having the positive leg. The entire leg is going. This is a brand new one, and its positive leg is going like that underneath, and here it's made in contact with this pad. And when the positive voltage is coming through this resistor here, is making contact on this pad or either that pad when the button is pressed. Pretty much that's it. This is the circuit for these two LEDs, and the other circuit on the other side is commanding the actual functionality of the device. And now I am already at the stage of making the capacitor bank. Here it is. So this capacitor bank that I'm having here, and I have a ton of cardboard prepared. It's actually quite fun to work with cardboard and gluing the cardboard and together and find and play around and find the proper position, proper dimension that you want. And if you want something bigger, like I'm doing right now, because I already made this board, but I figured out at the end, after I made it, that it should have been a bit more wider. Why? Because I have to put some text in line with everything, showing what values are there, and to help in general, And this is a colored line that I will put it like that. This is how I'm playing with pieces of cardboard, and then I will glue them together, and this is how this entire board will be. It's even smaller than this one. It's quite equal now when it's having all these spaces, too much spaces. And then I will put another cardboard underneath, and I will glue everything together on this longer cardboard, and that's it. And then I will start to make some holes, drag some wires to these pads from each jumper that I'm having here. And yes, every jumper is having one single pad there. And if we are looking here, you see they are bent underneath to be very strong. And this longer one as well is bended here and there. And they are quite stable. They are quite good, especially when I'm dragging from them. They are pretty sturdy. If I'm bending them like that, they will give up easily. But no one will do it like that. So it's only up and down. That's the only force that it must resist to. And luckily, this jumper that I'm having here, it's very easy to get out. But with one hand is a little bit, yeah, you see, very, very easy to get out. It's not catching very strong. It's catching kind of light, and it's good enough. It's good for this. Probably it's very used. I have brand new ones that are catching a bit too strong. And this is it. This is the second module layer. And then I will have the third layer with the 7474, which is here from the previous board. And I'm not sure if I will use exactly this board, probably, at least for this part, and then I will make a completion on the other part, make an extension. So yes, this is the step in the progression of making these boards. I hope you like it, and see you later. This is it. It's not very, very visible here, but with the naked eye I can see when it's made. Yeah, and this is the board, and from here to there, from this to this, and so on. Under here I made the holes, and I'm poking from here to the hole, from the back onto the respective pad. And it is very flimsy now, but it will not matter because this entire project will stand on something solid. And like this one, it is flimsy if you bend it too much or too forcefully, but it will usually stay on something solid, and the bendable part will not exist anymore. Oh yeah. Okay, all these four are here, are connected. Next, this four to this four, and module is done. You see how easy it is to be made? Very easy. Actually, this is the normal way I'm doing, since the spinning is like that, and I'm holding the wire down, and it's dragging the wire like that, but I'm holding it. And this is like my finger instead of my finger, this piece of wood. And it's doing the job extremely quickly and extremely well. That one is done. And I don't do this every day, so I kind of forget how to work with it. And when I'm filming, I don't remember exactly, but after I'm finished filming, I remember the proper way of doing things. I have to make a second take, you know? And it's very, very quickly and very, very well just doing it. This isolation. Yeah, excellent. It's not that quick, but it is quicker. No. It is quicker than making it with desisolating it with my knife. All right. All right. All right. I finished building it. I finished putting the wires to all the pads from all these jumpers. And now I soldered one capacitor here, but I have another two. Well, the rest, but two for now. And I want you to see how to solder capacitor. Or better said, how I am soldering. Is not really something unusual, but it's good to see how I'm working, I guess. And I'm sure, well, you can see what I'm doing here. But I can did it for sure identically. A bit too much heat dissipation. It's hard. Oh. Oh. Okay. For some reason. Okay. For some reason, it was 100 and it was doing a lesser. It was hard to heat up. I was wondering what the fuck is going on. Okay. Okay, good. A little bit of struggle, but now I have to bend this way in position. These are scrapped capacitors, by the way. They are not brand new at all. And but it doesn't matter. Okay. All right. Three capacitor. The beginning of the bank of the capacitors. All right. I hope you enjoy it. All right. All the capacitors, all the capacitor bank is assembled. I linked with only two wires I had to link. As you can see here, it needs only this wire from here to this rail, which is this wire here, from that point to this rail, and the negative rail, pretty much, which is somewhere there. And that's it, only two wires. And I already played around. This is with 100 nanofarads. Of course, if I'm pressing the button, it's stopping and starting again. And unfortunately, it's backwards in the sense that here is the lowest and this is the highest. And yeah, so this is 1 microfarad. Problematic, this 1 microfarads in my testings. This is 10 microfarads, and here is the fastest, and this is the slowest here when I'm rotating it towards it. And 100 microfarads is super slow. I exaggerated with the values. Here is the fastest, and is taking a ton of time until it's blipping. I'm not sure if this capacitor is even good enough, but well, I believe it is, but it's too much time. And yeah, 100 nano was the most responsive. It's blipping a ton a lot, and yeah, it's a bit disturbing having it inversed like this. Well, I will have to think on something, but until I will repair this little annoyance that I'm having here, suffices to say that I resolved the problem with the speed. On 10 nanofarads, it's so fast. I'm not sure if you even see it. It's imperceptible flickering right now. I'm not sure if the camera will catch, but I can barely catch it with my naked eye. It's a tremor like this. It's a very tiny tremor. This is the slowest, and here are the fastest. And yeah, it's okay. It's good. I like it. We will see with the motor, because all of this add-on update, this upgrade that I'm making with the capacitor banks and the jumper, all this trouble I make it for the speed of the motor, to have various speeds and to be able to command the motor a little bit more easy on the speed dial. You know, it was too abrupt before. When I was having only one capacitor, it was working fine until a point, and then it was abrupting, getting extremely fast, and that's why I made this capacitor block pretty much with various timings. Yeah, okay, it's good enough for now, and I'm happy until here. Next I will have to add this 74 block, and somewhere here in the bottom also a NOT gate. I will have to make it and insert that NOT gate here as well. I will have to make it with transistors. I believe it is already made or partially made here in what I'm having in my hand. It is already made from my previous build, so I don't have to build it anymore. So I will have to check it out and verify which pin is. But it looks like it is the correct thing that I'm having here. And it is the SMD version. And I will have to add some other wires here and here probably for positive, negative, or I don't know what it had before, but for sure it's having 4 wires, positive, negative, and input and output pretty much. And this is the NOT gate made from SMDs, 2 resistors and 1 transistor. Very, very simple. I like it. And yeah, pretty much that's it. We will see. Hello. I managed to make it, and it's working. I didn't film anything for a while because, to be super sincere, I was quite unsure if it will work again because of my operation that I cut it there, and it was hard. It was a bit hard and a bit risky. It shouldn't have to be risky, but it was risky. But in the end, I managed to make it work. It is working as before, exactly as before. I had this problem before as well. For some reason, it just started to behave erroneously, as you can see here. When one lit, let me slow it down, like that. Let me actually change the jumper to something else that is a bit more slower. So this is best. This is good. Oh, look, it's working fine. Here. So for each LED that is running here in sequence, 2 of them should lit there. But it's having some errors, clear errors. You see, when is this? The second, this one. It should be this 2, and probably, or this 2. I don't know. Yeah, but it should follow this line as here, 2 by 2, and here 1 by 1. And when I built it originally, it was working exactly like that. But for some reason, I have no idea. And I highly suspect this very bad diodes that I try my best to reuse them, but sometimes it appears that some components are not good to use them, or they are something else. They have some other properties inside them that are not really like any other, like the large majority of the diodes that I'm usually using. These are 1N4148. I prepare them because I have two for each zone, and I will change them. And I bet my money that I don't have on these diodes that are bad. They give me some bad results here as well, and I still keep some of them. But I will have to change those as well because they proved me numerous times this is. They don't like to work in this kind of circuit. They like to work in some other circuits. I have no idea where and how, but they are very sensitive, and no, I don't like them. So they don't do a good work in this configuration. All right, so the rest of the circuit, it is behaving as expected. If I'm putting a higher speed here, let me put it like this, and even faster if you want. You see? And look on those, and this one is not even showing anymore. But I will put it at a medium speed for our video here. And here is, when I'm pressing this button here, is switching to manual mode, and when I'm pressing this button here, it will count. Come on, I have this little catch there. So it will count when I'm pressing that button. It will count to a certain number that I'm setting it here. I believe is 7 set here, and it is counting to 7. You see there. And only when I'm pressing that button is doing that and stopping and waiting for my input, and it's working absolutely fine. Of course, this button is the same button that I had it before, and it is still a little bit funky when I'm pressing. I have to press it multiple times until it's actually making contact for some reason. But this is a minor bug. I can get over it, you know. Come on. And yeah, I should change it. I will see. Here is this button as well is having some problems. I don't know. And let's see. Yeah, see how all of them are lit? Very strange, very strange. It's leaking. Something is leaking there. Something is leaking back, and it shouldn't. You see this? No. And or like this. You see? No. And also here I have a ton, 230, but usually it's not like that. If I'm changing it like this, it's 90. So it's clearly something that from this side, when I'm switching, it's clearly doing something bad. It's either a chip I have no idea. I know one chip fucked up, but I hope not the other one. Yeah, again, 200. Huh. Yeah, I have some little problems here to resolve now. But the main... Hold on, yeah. The main circuit is done. So at least this part is finished, and I'm very happy about it. Now I can intervene and repair it more easily than it was before. It's more visible. It's still complicated as it is right now. As it is now, it's still complicated, but it's a bit more spacey. And I can actually enter with my soldering iron and actually do the job of repairing or changing or upgrading, changing the values or something, changing the capacitors there. And pretty much that's it. This was the part that I took it out, and now I put it in, and I glue it. Everything is glued. There is not staying by itself. On these two boards are glued also, and this is not glued, and this one is not glued. they are floating, but yeah, it's good enough. It's good enough. I'll have to resolve this problem that I'm having here, and go back to business and see how it will behave with a stepper motor when I will change this different speeds and then switching from that potentiometer there. I will see. Alright, goodbye for now, and see you later. Bye-bye. And it's good when I am right. Let me make a little bit of contrast. And it's already working as it should be. As you see, I have no errors anymore. When it's here, when the first one was lighting, all four was lighting, and it was giving me errors. So now when one here is lighting, two of them are lighting in parallel with what I'm having here, pretty much. And cool. It's like I said, I changed the previous diodes, which are very weird diodes. Probably they are specialized. They have their own specialty in some funky circuits that I never heard of. They have a special composition inside them, but for sure they are not like rectifying diodes like 4148. These are rectifying diodes and fast diodes as well, switching very fast. I'm not sure if it's the switching, but it's the composition inside them. I believe those are making trouble. And I left two of them. They are still there, the old ones. And only 3 compartments I changed, and it's already working as it should be. But I will change those as well. It's a bit harder because I have to unsolder these blue wires that I'm having here, and then solder them back. It's a bit of a trouble. But I wanted to show you that my hints, no, that my predicament that this were the problem, diodes were the problem. It was correct in the end because I kind of know what I used. I wasn't completely sure. I changed these 2 modules and it was still giving me errors, but it was giving me a slight lesser error than previously when I didn't change, before I changed anything. Slightly less difference. It was affecting, but not that much. It was here in the middle, in the third one, the bad one probably. When I'm checking them, they are all good, but when in the circuit, fucking hell, they are messing up everything. And I was thinking when I changed this 2 and nothing happened. Before observing that slight less error behavior, I was starting to think maybe are the transistors, because they were the next ones to change if the diodes were not the problem. I was thinking to change the transistors. Thanks God I don't have to change them, because it is changeable, but it is not easy to change them. And I don't want to change them anymore. So yeah, it's working okay now. That's why I like slow speed like I'm having right now, because I can actually see the problems. And even now I'm on 1 microfarad, and if I'm putting it on 10 microfarads, holy fuck, it will take a very long time to switch between them. And I have even 100 microfarad. Yeah, I will probably change those numbers there. Probably I will see in the future. All right, I changed this last 2 diodes here. Everything I took it out there. So the 1N 4148 are here as well. I relinked the blue wires, and I tested it and it's working okay, but I noticed something interesting, which is not from the diodes anymore. I believe it's from the chips themselves. Either they are missing something, a capacitor on their immediate rails, like positive or negative rails, a capacitor there. It's my highest suspicion. It might be that. But check this out. When I'm switching from one side, only one chip is giving error, not the other. When I'm switching from one chip to another, pretty much when I'm pressing this button, it's changing between the these 2 integrated circuits, because one is sending the signal one way and the other inverse way. And that's how I'm making the inversing from top to bottom, or from bottom to top. You see, when I'm changing here is in the other sense, and here as well. And let's see. I believe this is the chip that is creating problems. When I'm switching now to it, yeah, you see 21. You've seen that 21. 20. It was holding a little bit more last time. A bit more time, and I was suspecting those diodes, they are letting this old diodes that are letting some unwanted current to pass and to fuck up my circuit. But I had a problem when one chip was burned. I believe this one was burned, or that one. I don't remember. I believe this one, the first one, and there's the second one. I don't know. Maybe it's damaged. It's still working, but in a damage. But only when I'm switching to it. When I'm switching back to this one, nothing happens. It remains on. You see 8. Now I switch it to 8, 9 is changing a little bit when these LEDs are changing here. But when now I'm switching back. You see 23. It jumps. and I switch it back to this one, and yeah, it's not a big deal, I guess, but it shouldn't jump like that at all. These are very tiny details that I am observing them while constructing all this thing. I'm very extremely familiar with this circuit, as complex as it is. Like I said, and it is showing, I'm working with modules, and it's very easy to. It's not very easy, but it's much more easier to spot a problem and to point my finger towards something because of this modularity that I'm using everywhere. And it is looking like it's one single circuit, but in reality they are modules, and that's how I was thinking all the time when I built this thing. And yeah, I'm very proud of it actually. I really like it. I really like it, and I wish it could be what I imagined from the first time. From so my original idea with all this entire circuit is to test drive stepper motors, to see them how they are working at their maximum potential and at their correct sequence frequency or whatever. So pretty much to change the frequency, how fast is sending the signal, and also the speed of the motor, pretty much, and to check that, how slow can run and how fast they run, and also how to make them running, because there are 4 wires motor, stepper motors, 5 wires, and I want to on 6 wires, and I'm thinking on that, but for now only for 4 wires and 5 wires I make it, and for now is only sending the correct signal, and it's 2 modes of signal. When I'm changing from here, everything here is stopping, and it's sending only this signal to these guys here. When this LED is lighting up, it's taking the signal from these guys, and only one transistor is opening per, you see, and the rest are floating pretty much, are not doing anything, and that's how it's working. It's lighting up only one transistor and one output pretty much, and sending and when I'm sending 2 of them, now I'm switching to these guys, to these transistors, one LED from here is converted into 2 LEDs here, and these 2 LEDs are opening 2 transistors at one time, as the LEDs are showing here, exactly like that. If these 2 LEDs are open, these 2 transistors are open. If these 2 are open, these 2 on the top are open, and so on, and are sending the positive on those outputs, and the rest are floating pretty much, not doing anything. What I was trying to say with this is that yeah, driving, this is the main goal of this project, to drive effectively and very efficient, to test drive stepper motors and as many wires as possible they have those stepper motors. Hopefully that was the idea, to test every kind of stepper motor that I can put my hand on, and like this is an universal stepper motor driver pretty much. That was my idea, and I did quite a good deal of it. I must praise myself. But we will see how I will link everything to the other side of the board, because I have their other chips to be linked to these guys, and actually make the board even bigger down here or there, I don't know. We will see.
What I have here is the last good circuit. This is the last one that I used and that I cleaned it up. I remember here I was having a resistor, some capacitors here, here probably. Also this part here, it was having some capacitors. And this is the actual circuit that I used. And let me show you this last down part that I'm having downside. Okay, this is how it's looking. Right now on my board that I built it. This diode here is not in the circuit. It's here from a simulator bug. But this inverter, I have it also here. Instead of a chip that is using a NOT gate, I actually use the SMD components that you've seen in the movie, and that's it. Here is the 3D model itself, and I've updated the circuit, especially here in this area, in this sector with the 7474. I actually, and also the NOT gate, you see, I actually resync its position, and I was working in parallel with the board in reality, and then I was coming back, I was jumping back in my chair on my computer and changing here in the 3D, and kind of having a little bit of feeling of how it will look or feel in the future, and on the cardboard. And it did help me working in these 2 worlds, in the reality and here in the 3D world. And I actually modeled what I did in reality, I modeled it here in 3D as well. Of course, the wiring are much more cleaner here in 3D, but in reality it's full of wiring, unfortunately. I couldn't get rid of them. I mean, to look more cleanly in reality. I'll see about that in the future when I will find a way, building circuits with more cleaner wiring than it is right now. But it is what I even, no, I didn't. I even changed the color exactly how I use it in reality. This color, this green, blue-green color that I'm having here on the wire is actually as in reality as well. And also the placement, and I made very small modifications, but important ones. Probably most of you have seen these 2 capacitors on the top of the 555 circuit. These capacitors are here for helping a little bit the functionality of the chip, of the 555 chip, and because they are on the top here, it's kind of easy to add them later if I feel the need, but for now I didn't include them in my circuit in reality. Not even in my circuit, yeah, here in the circuit schematic they are as well, but yeah, it's working without them fine, and they are occupying a little bit too much space, but it is more correct to include them because it's protecting, they are protecting a little bit more, and the 555 will be more happy with those capacitors there. But other than that, it's what I'm showing you right now is exactly this is the circuit, exactly how I'm having it in reality. Because like I said, what I worked in reality, I jump back here in 3D and I modify it, and what I modified here in 3D, I jump back there in reality and build it very, very close to how it is here in the 3D world. All right, this is it.
Thank you very much for watching. I hope you like it, and I hope you like my problems and how I solve them. And see you later. Bye bye. Bye bye from Romania, from your favorite artist electronics, Q12. Mr. Q12, remember that. It's Mr. Q12. Bye bye. Bye bye.